Today we're going to discuss the two-node direct connect feature in vSAN 6.5. Two-node support was introduced in vSAN 6.1 and it's also supported in vSAN 6.2. We do require a witness appliance to provide quorum for the two-node cluster. The solution is very easy to deploy and we support hybrid and all-flash configurations. The vSAN network must have connectivity to the vSAN interface of the witness appliance. This is typically over a low bandwidth link. We do require high-speed networking between data nodes in cases where we have a larger number of virtual machines or when using an all-flash configuration. In vSAN 6.5, we now have the ability to directly connect each data node using one or more crossover cables. This is because we can now split vSAN traffic by type. This is done by separating vSAN data traffic from vSAN witness traffic using different VM kernel ports. Two crossover cables may be used for redundancy, and we do recommend 10 gig connectivity. One cable could be used, but is not recommended. By separating witness traffic from the vSAN traffic on a separate network, vSAN 6.5 provides additional flexibility at a lower cost because high-speed switching is no longer necessary for the vSAN data. We can take a look at a cluster we have configured with vSAN 6.5 two-node with the Direct Connect feature enabled. We'll see that we have a cluster with host 1, host 2, two nodes. With our HQ witness appliance, we see that we have two-node properly configured. If we look at our hosts, we'll see from a networking perspective a distributed virtual switch, some 1 gig switched connections, and some direct connect 10 gig connections. If we look at our VM kernel adapters, we'll see VMK0 as a management interface. VMK2 has vSAN traffic enabled. That's our data network. VMK3, we have vMotion. If we look at our physical adapters of the host, we'll see we have 3 NICs on vSwitch 0, which is handling our VM traffic. And we have VM NIC 3 and 4, which are 10 gig. They are not connected to any networks. They are in fact directly connected to host 2 on NIC 3 and NIC 4 respectively. Now, if we look at our physical connections with our virtual switches, if we look at our distributed virtual switch, we see that vMotion is connected to one uplink and vSAN is connected to the other uplink. It's important to keep in mind that because these are directly connected to each other between host 1 and host 2, there is no route to the witness appliance. To be able to get to the witness appliance, we have to go to a command line and we have to enable another VM kernel interface, such as our management interface, for vSAN witness traffic. Before configuring the cluster, I remoted into host 1 and host 2 and ran the following command: ESXCLI vSAN network IP add -I VMK0 my management interface and -T equals witness as my traffic type. vSAN network listing, I now see that VMK0 is tagged for witness traffic. That's our management interface, which is switched and goes out across the network to our witness appliance. Our vSAN VMK2 kernel port is directly connected to the alternate host. By separating this witness traffic and this vSAN traffic, we no longer have the requirement of high-speed switching between nodes. which will provide a lower cost solution when deploying two-node virtual SAN in remote office and branch office environments.